Okay, so the first problem that we suggested was merge two sorted lists. And so like the way that I dealt with this was first I had a pointer that pointed to both the heads of list one and the heads of list two, like right over here, I set them. And then I like accounted for the case for if they're both empty, then I return none or null. Um, and then, so if it's not the base case, I want to, um, I'd want to return a new list that contains all of the elements from both lists, but in a sorted order. So I create a dummy node um, to be the starting point of that new list right here. And then I set like a dummy current pointer that I'll use to like um, add new elements to the dummy list. And then there's this value, like smaller value that I'm using just to like figure out like of with it between the two lists, like which like between the elements that we're comparing in the two lists, like which is the smaller value, because like the algorithm that I was using was like while you have these two lists, you like would start by like comparing the elements at the first part of the first elements of each list. So like the current pointer would be the point of comparison would be like this one in list one, and then compared to this one in list two. And then because both of those are the same, I just use set smaller values to the list one's current value, which is like this one in red. And then I would update the list one pointer to point to the next node, because that so that like in the next time that I'm like in this while loop, I'll be comparing that node that hasn't been added to the new dummy list. I'd compare that node to the one that's in the other list that also wasn't added. So like the way that this would work was like I'd check these ones, like take one of the ones into the dummy list and then like compare this one and that two. And then I would um, choose the smaller value and then update the pointer to point to the next value, like compare the 2 and 3. And so like it would add them in order. And then if, okay, so then there's a case where I could reach the end of a list and there are still elements left in another list. So to account for that, I would do the I would just like add like the remaining elements of that list to like the dummy list, and then I'd return whatever the dummy list like I'd return the head of the new list that I created that has everything in order. Does that make sense to everyone? Does anyone have any questions? Okay, awesome. And then I'll explain the next one, which is remove nth node from the end of the list. So in this one, the way that I approached it was I have another dummy node that I'll be using to traverse through this list. And then like basically I just use it to like set the head of I just set the like dummy dot next to the head of this list. And then I like the way that I was able to do this like just in one loop is I have like a slow pointer and a fast pointer. So like my reasoning for this was like like an initial way that you might want to solve this problem is by like going through the entire list first, like counting the number of elements that are in the list, right? And then like once you know the length of it, you know what position length minus n is, and then you'd be able to extract that. But if you'd be able to remove that from the list. But if you didn't, if you only wanted to go through it once, there's another way to do it where you have a slow pointer and a fast pointer. So you'd basically, you'd always want like the distance between the fast pointer and the slow pointer to be n, because and then you'd want to move the fast pointer to point at the last element. So like for example, like if I made it so that the fast pointer pointed at the last element in this list, which is this 5, and then the slow pointer should point to the element um, that's that's at the fast pointer's location -2. So the slow pointer would point at 3. You know that that is pointing to the element that's right before the one that you want to delete. And so like the way that I handle like or code this is that I first increment the fast pointer. Um, so because I'm given like n equals 2, in like this example, then I increment like the fast pointer from like the beginning and then like decrement n so that initially like this fast pointer will go up position of n times. And then once like n has been decremented enough to reach 0, then that's when I start moving the slow pointer, because that's the point where I know that the slow and fast pointer are n elements apart. So um, and I like make sure to do that until like fast dot next is null. So that means that it like when it leaves this loop, the fast pointer is pointing at the end element, and then the slow pointer is pointing at the element that's length minus n, at position length minus n. And then the last step that I have to do is just like skip over that node that's at position length minus n. And like the way that I do that is like slow dot next shouldn't point to what it currently is, because like slow is pointing to 3 and it's slow dot next is pointing to 4. You want slow dot next to instead skip over that and point to what's after. So that will effectively like delete it from the list, and then you return the head of the list again, which is dummy.next. Does anyone have any questions we want to type in the chat or say it out loud?
Could you go over what the purpose of the dummy is again?
Okay, so you can do this problem without the dummy. I think it's just like usually it's simpler to just like use a dummy node in general, because it like gets rid of the case of like creating um, a head based off of like different conditions. So like in this case, like you don't have to like add stuff to dummy node. Like it's just like pointing to head. Like you could just return head instead. But like in a case where you're like adding stuff to like a new list, like in the merge to sorted lists example, like it's better to have like a dummy node so that like you don't have to check if the list is like null before adding a head. So you get rid of like that special check, because you're assuming like it already has like a node that you can add things to. Does that make sense?
Makes sense. Thank you.
Okay. Okay, any other questions? Okay, awesome. Then I will stop recording